Welcome to the lecture series of multiple integrals. Today we are going to see problems under double integration. Look at the question. Evaluate double integral 0 to pi by 2, 0 to pi by 2 sine of theta plus phi d theta d phi. So look at the solution. Let I is equal to double integration 0 to pi by 2. What is given in the question, we will take it as I. Sine of theta plus phi d theta d phi. First integration with respect to theta. So 0 to pi by 2, integration of sine is minus cos. Okay, so minus cos theta plus phi with the limit 0 to pi by 2 d phi. You can take the minus outside. Integral 0 to pi by 2 limit for theta. So cos pi by 2 plus phi upper limit minus lower limit is 0, cos 0 plus phi. So cos phi into d phi. Cos 90 plus theta. Cos 90 plus theta is minus sin theta. So cos 90 plus theta equal to minus sin theta. So minus integral 0 to pi by 2 minus sin phi minus cos phi into d phi. On the whole we can take the minus outside. So already one minus is there. So that will become as plus sin phi plus cos phi into d phi. Now we are going to integrate with respect to phi. Integration of sin phi is minus cos. Okay, so minus cos phi with the limit 0 to pi by 2 plus integration of cos is sin with the limit 0 to pi by 2. So minus cos pi by 2, minus of minus plus cos 0. Okay, upper limit minus lower limit. Here also sin pi by 2 minus sin 0. Cos 90 value is 0, sin 90 value is 1, cos 0 equal to 1, sin 0 equal to 0. So we have to remember all this result. So minus cos 90 is 0 plus cos 0 value is 1, and then here it is sin 90 is 1 minus sin 0 is 0. So the answer is 2. Therefore the required answer I is equal to 2. Look at the next question. Evaluate double integral r power 4 dr d theta over the area of the circle r equal to a cos theta. So in this question, integration with respect to r and theta, and the limit is not given directly. Instead of that, it's given that over the area of the circle r equal to a cos theta. So look at the diagram. R equal to a cos theta. Okay, if you are taking theta is here, actually this line is minus pi by 2 to plus pi by 2. Okay, so obviously wherever we are taking in the circle, r varies from 0 to where? 0 to a cos theta, and theta varies from minus pi by 2 to plus pi by 2. So from look at the figure and we can identify the limits of the given circle. So the region of integration, okay, so it's given in the question, the region of integration is over the area of the circle r equal to a cos theta. Okay, so now we are going to find the limit for r and theta. Look at the diagram. Here r varies from, it starts from 0. Here it isn't it. So on the whole circle, wherever we are taking a point, the value is what? R equal to a cos theta. So r varies from 0 to a cos theta. Likewise, if you are taking the value, that is the limit for theta, theta varies from, this line is minus pi by 2. So theta varies from where to where? Minus pi by 2 to plus pi by 2. So the limit of theta is minus pi by 2 to plus pi by 2. So in the given integration, what is our given? Given I is equal to double integral r power 4 dr d theta, isn't it? So now we got the limit for r and theta. What is our r limit? R limit is 0 to a cos theta, and theta limit is minus pi by 2 to plus pi by 2. First integration with respect to r. Okay, so which is equal to minus pi by 2 to plus pi by 2. Integration of r power 4 is r power 5 by 5 with the limit 0 to a cos theta. into what? Into d theta. So now we are going to apply the limit. So we can take the 1 by 5 as a constant. So minus pi by 2 into pi by 2. Look at this, a power 5 cos power 5 theta d theta, and the lower limit is 0, isn't it? So a power 5 is also a constant, so we can take that also outside. A power 5 by 5 integral minus pi by 2 to plus pi by 2 cos power 5 theta into d theta. Okay, now cos is a even function, so we can write this as, instead of minus pi by 2 to plus pi by 2, this can be written as 2 times of the integral 0 to pi by 2. Okay, 0 to pi by 2 cos power 5 theta d theta. Okay, is it clear? Because minus pi by 2 plus pi by 2 function is even. In that case, we can write this as 2 times of the integral 0 to pi by 2, since cos is a even function. Now look at this, 2 power 2 into a power 5 by 5. Now look at the 0 to pi by 2 cos power 5 theta d theta. 5 is a odd number. When n is odd, we have a result. What is that? N minus 1 by n. Okay, into n minus 2, etc. It will go, the last term is 2 by 3 into 1, since n is odd. When n is odd, we have a result. What is that? N minus 1 by n into n minus 3 by n minus 2, etc. 2 by 3 into 1. So based on this result, we can write this as, here n is 5. So we can write this as 4 by 5, 2 by 3 into 1. Okay, so because of the result, n is odd. Okay, when you are multiplying this, we can get the answer as, so it is 16 a power 5 by 75. So the answer of the given integration I is equal to 16 a power 5 divided by 75. Look at the third question. Evaluate double integral 0 to pi by 2 and 0 to a cos theta r square dr d theta. Here also integration with respect to r and theta. So we can take the integration I is equal to, given 0 to pi by 2 and 0 to a cos theta r square dr d theta. Here also integration first with respect to r. So 0 to pi by 2, integration of r square is r cube by 3, 0 to a cos theta d theta. We can take the 1 by 3 outside, it's a constant. 0 to pi by 2 r cube, that is a cube cos cube theta, minus lower limit is 0. Okay, into what? Into d theta. So now a cube is also a constant, we can take outside. Integral 0 to pi by 2 cos cube theta d theta. This sum is also similar to the previous problem. Look at this, 0 to pi by 2 cos cube, n is odd. Okay, so here also we are going to apply the same result. So that is equal to a cube by 3 into 2 by 3 into 1. Okay, because n is odd, since n is odd. Okay, so therefore I is equal to 2 a power 3 divided by 9. Look at the next question. Evaluate double integral 0 to pi by 2, 0 to 2 r dr d theta. So the solution is I is equal to 0 to pi by 2 and integration with respect to r. So that is r square by 2 with the limit 0 to 2 d theta. Can take the 1 by 2 outside. So 1 by 2 integral 0 to pi by 2, upper limit is 2, 2 square is 4. So 4 minus 0 into d theta. 4 is also constant, we can take outside. So 4 by 2, 0 to pi by 2, only d theta. So we can cancel this, we can get 2, integral 0 to pi by 2, only d theta. So theta with the limit 0 to pi by 2. So 2 into pi by 2 minus 0, we can cancel the 2 also. Our answer is pi. Therefore, the required answer I is equal to pi. Okay. Look at the next question. Evaluate double integral 0 to pi, 0 to cos theta r dr d theta. So the solution is let I is equal to integral 0 to pi or integration first with respect to r. So r square by 2 with the limit 0 to cos theta d theta. Okay, 1 by 2 we can take outside, 0 to pi, upper limit is cos theta. So we can get cos square theta minus 0 into d theta, that is 1 by 2 integral 0 to pi cos square theta d theta. Okay, here cos square theta into d theta, cos is a even function. So cos square theta can be written as cos square integral 0 to pi cos square theta can be written as 2 times of the integral 1 by 2, 2 times of the integral 0 to pi by 2 cos square theta d theta. Okay, so now we can cancel the 2 also, and integral 0 to pi by 2 cos square theta n is even. So n is even means n minus 1 by n minus 3 by n minus 2 etc. The last one we can get pi by 2. So applying that result we can get 1 by 2 into pi by 2. Okay, here n is 2. So 2 minus 1 by 2 into what? Into pi by 2, because n is even. Therefore, our required answer I is equal to pi by 4. Okay, thank you for watching.